Let us do one more problem on Y parameters. So this is a little bit complicated circuit. So in the two port, always remember input side is always V1, I1, output side V2 and I2. In between whatever is there, that node is third node, I3, V3 and all it will come. So this is V1, this is V1, this should be V2. In between nothing is there, that's why this there is no resistance, so same, this point is same, so we can consider this also V2 only. So this is one more node, we can consider this as V3 and this is ground reference node. Okay, I1 is always like this only, input side. I2 is this side only. If in a two port network diagram, you know that. Okay, this is I1 and this is I. In between we have one more circuit, so here you can use different notations, but this should be I1, this should be this should be I2, this should be I1. Okay, now let us write expression for I1. I1 is potential difference, so V1 minus V3, this is considered as 3 not 2, because in two port network this is V2. So V2 means here it should be V2 and there is no resistance, no, same, this voltage will be same as this, so this is V2. One more extra node is this is V3. So V1 minus V3 by 1. Okay, and you can apply KCL at node 2, node 3. This is a node 3. If I apply KCL at node 3, this current is equal to, okay, you can write like this, or you can write all the currents going towards the node, or you can write all the currents going away from the node. But in the two port network, we are assuming I1 going towards, I2 is also going towards the node. So in between, you can assume like this. This current is going to divide between this and this. So I1 is equal to, okay, this current. If I apply KCL at node 3, current entering the terminal is I1. Current leaving from the node is V3 minus 0. Okay, V3 minus 0 by 2, V3 minus V2 by 2. And you can simplify this. Okay, V3 by 2 plus V3 by 2 is equal to 1, because half V3 is 1 and half V2. Okay, that is the value of I1. Again, you can substitute here V1 I1 value is V1 minus V3 and get expression for V3. Get expression for V3. Okay, and finally that I3 value to substitute. So here actually in Y parameters we should get I1 and I2 in terms of V1 and V, but we got I1 in terms of V1 and V3. I have to eliminate this V3. So how to get eliminate this V3 is apply KCL at node 3. Apply KCL at node 3. This is I1 is nothing but same this one only, V1 minus V3. And if I apply KCL, another two currents are V3 by 2 and V3 minus V2 by 2. So get expression for V3 from this expression. You're going to get, here it's continued. Here it is continued. So you're going to get expression for V3 as this. Expression for V3 as this. And this value of V3 we have to substitute in the equation number 1. We have to express in term here. I will repeat once again. Get expression for V1, that is I1 is V1 minus V3 by 1. Okay, but I1 in Z parameters, I1 and I2 are expressed in terms of V1 and V2 alone. But V3 is there. I have to eliminate V3. How to eliminate V3 means apply KCL at node 3. So which is I1 is equal to this minus this. Again I1 value is in terms of voltage, it is V1 minus V3 by 1. Okay, and you get expression for V3 from this expression. Okay, V1 minus V3 by 1 is equal to half V3 is 1 V3, V2 by 2. And if you simplify, V3 is equal to V3, if I bring it to, we'll write here steps. Okay. V1, I will bring this one to left side. V2 by 2 is equal to this V3. If I bring it to right side, it becomes plus. So V3 plus V3 is 2V3. So V3 is equal to V1 by 2, V2 by 4. Okay, you have to 2V3 is this much. 1V3 is again you have to divide by 2. So V1 by 2, V2 by 2 by 2. It is V2 by 4. This V3 value you have to substitute in the equation number 1 so that you will get the first equation. Similarly, to get the second equations, apply KCL at node 2. Apply KCL at node 2. In the node 2, current is, here there is no resistance. Okay, no need to write in terms of voltages. So I2 is equal to down current and this current. Okay, so what is the expression? It is I2 is equal to V2 minus 0 by 4, V2 minus V3 by V2 minus 0 by 4, V2 minus V3 by, you can write like this here, this is equal to this much and this current is equal to this much. This I2 is equal to V2 minus 0 by 4, V2 minus V3 by 2. And if you simplify this, again here also, after simplification you get V2 and V3. But I want I2 is equal to in terms of V1 and V2. V2 term is there, but the V1 is not there. So you have to substitute the value of V3 and remove this V3 term and get expression for V1 and V2. So if I substitute here value of V3, which is half V1 and V2 by 4, and simplify, we'll get I2 also in terms of V1 and V2. Here you can see, if I after substitution, you can do this 3 by 4 V2 minus V1 by 4, half into V1 by 2 is V1 by 4, minus into plus is minus V2 by 8. Okay, here V1 term is only 1 by 4. Okay, 1 by 4 V1 and 3 by 4 minus 1 by 8. 3 by 4 minus V2 is common. If you take V2 common, 3 by 4 minus 1 by 8. 3 by 4 minus 1 by 8, you're going to get 5 by 8. Okay, so let me show that. 3 by, you have to click down, 3 by 4, then again you write the number minus 1 by, again 1 by 8 no fraction, 1 by 8, you will get LCM is 8. Okay, LCM is 4 into 8. 4 and 8, if you take LCM 8, so 4 2s are 2 into 3 is 6. 6 minus 1 is 5. So 5 by 8. Those are good in mathematics. They can take LCM and they will do. Those are weak, slow learners. You can follow this method so that you will not get. Otherwise, you can calculate and you can put answer in fractions only. You can write 0.25 V1 and 5 by 8 how much you will get, that you can write. So this is y11, y12. This is coefficient I2 is expressed in terms of V1 and V2 only. This is the y21 and this is y22. And they asked whether circuit is symmetrical and reciprocal. For symmetrical, y11 should be equal to y22. So it is not equal. Whether it is reciprocal, check y12 is same as y21, minus 1 by 4 minus 1 over 4. So it is reciprocal, not symmetrical. Okay, thank you.